Okay, so we're going to talk a little bit about equilibriums, which we kind of discussed in class last Wednesday. So what we're interested in here is critical points. Now, I don't have the notes printed out, but I'm just going to sort of copy it. So I want to consider a population that has a carrying capacity of 500, a growth rate of 0.2 per day, and a death rate of 0.15 per day. So remember that carrying capacity means that we have logistic growth. So let's go ahead and let N be our population. So this is a rate of change. So the change of the population, we have our growth rate times our carrying capacity value, which is divided by that carrying capacity, times by the value. Then we have minus this extra death rate. So remember, before we looked at some critical points. So critical points are when this equals 0. So let's make the derivative 0. And that means that the rate of change isn't changing, it's 0. So I'm going to just go ahead and simplify this here. And combine like terms. And then because I have an n squared and an n, remember this means that I need to factor. We don't want to solve directly or I'll lose some information. So each of these could be a critical point. N equals 0 and 0.05 minus 0.2 divided by 500 n equals 0. And if I solve this, I multiply by the reciprocal. This will give me 125. And so these were critical points, but in terms of differential equations, these are also equilibrium solutions. They in and of themselves are equations, n equals 0, n equals 125, and they're solutions to this differential equation. So if I wanted to verify that, remember I would just take the derivative of my equation, plug in my values, and make sure that it was true. And if I do this, I will get 0 equals 0, and I put that in the notes. So you should look at that.